Hello, students. I am Diao Xinxing. Today, I will give you a course on water pollution control technology. Next, let's learn biological treatment technology part, activated sludge process, operation mode and process of activated sludge process. There are mainly 5 parts. 1. Decreasing aeration method. 2. Stage aeration method. 3. Adsorption biodegradation. 4. Completely mixed method. 5. SBR method. 1. Decreasing aeration method. The decreasing aeration method is to increase the available aeration volume, then with the gradual decrease of organic matter concentration, and correspondingly reduce the amount of ventilation, also known as decreasing aeration method. The decreasing aeration method is to solve the problem of traditional activated sludge method, difference between oxygen supply and oxygen demand. The aeration is gradually reduced along the length of the tank. That is, the oxygen supply at the head end of the pool is large, the way of small oxygen supply at the end of the pool. This way, save the number of aeration equipment in each section in the regulating tank. To achieve differential support, compared with the traditional activated sludge process, the total oxygen supply is saved. Decrease. The air leading into the pool has been effectively utilized. Energy is saved. 2. Stage aeration method. Adjust the water inlet point. The wastewater flows in at several points along the aeration tank, also known as multi-point inflow method. The oxygen consumption rate at the front end of the aeration tank can be reduced. Avoid hypoxia. Improve the utilization rate of air. By adjusting the way of water inflow, improve the utilization rate of air. Reduce energy consumption. As shown in the figure, this is the process of stage aeration. 3. Adsorption biodegradation, also known as AB method. In the 70s, German professor put forward AB process. The aeration tank is divided into 2 sections with high and low loads. Each has its own sedimentation and sludge reflux system. Adsorption section adopts high load or ultra high load operation. Short residence time, about 30 to 60 minutes. It is mainly an adsorption process. The removal of B0D can reach more than 50%. Section B of oxidation section adopts low load operation. The stay time is 2 to 4 hours. As shown in the figure, it is the process flow chart of adsorption biodegradation method. Wastewater enters the aeration tank of section A. Rapid adsorption of organic pollutants in aeration tank. Immediately after entering the medium sedimentation tank, the medium sedimentation tank precipitates the activated sludge of the system. Most of them can be returned to the aeration tank in section A. A small part will be discharged through excess sludge, wastewater from medium sedimentation tank. Then, it will enter the aeration tank of section B. In the B section aeration tank, organic matter in wastewater will be further degradation of activated sludge. Finally, it will enter the secondary sedimentation tank. The secondary sedimentation tank precipitates activated sludge. Most of them return to the aeration tank of B section through sludge. A small part will be discharged through excess sludge, supernatant from secondary sedimentation tank. It can be discharged through the water outlet. Characteristics of AB process. A stage adsorption stage, high organic load, F more than 2 kg per kilogram per day. Dissolved oxygen is about 2 to 5 mg per liter. B in a state of hypoxia. HRT is also known as hydraulic retention time, in 30 to 40 minutes. The mud age is about 0.3 to 0.5 days. Large sludge output, but also has adsorption. The content of organic matter is high, such as anaerobic digestion of sludge. Most of them produce more than 25% gas. At the same time, it also has a feature that the impact load resistance is relatively high. So our paragraph B, also known as biological oxidation section. Its biological load, less than 0.15 kg per kilogram per day. The dissolved oxygen during aeration is 2 to 3 mg per liter. B in an aerobic state, the hydraulic retention time is about 2 to 4 hours. The mud age is 15 to 20 days. Sludge is characterized by small amount of sludge, only 1/4 to 1/3 of the traditional process. 4. Completely mixed method. Complete mixing method appeared in the late 1950s, used to treat high-load industrial wastewater, especially industrial wastewater containing inhibitory organic matter. After the wastewater and the return sludge enter the aeration tank, immediately and completely mix with the original mixed liquid in the tank. Characteristics of complete mixing method. 1. Microbial species in various parts of the pool solution, and the quantity is basically the same. The living environment is basically the same. 2. When impact load occurs in inflow, the composition of the pool liquid also changed little, because the sudden increase in load is shared by the whole pool mixture. Unlike the push flow type, it is only borne by part of the return sludge. A fully mixed pool is, in a sense, a large buffer. It has some advantages in the treatment of industrial sewage. The oxygen demand of each part in the pool liquid is relatively uniform. 5. Sequencing batch activated sludge process. Sequencing batch activated sludge process is a batch operation, sewage treatment process. Each operation cycle of the process can be divided into 5 stages: water inflow period, reaction period, sedimentation period, emission period and idle period. As shown in the figure, it is a sequencing batch activated sludge process in operation. So next, please see the students' schematic diagram of process flow of sequencing batch activated sludge process. Operation cycle of sequencing batch activated sludge process. The first stage is the inflow stage. At this time, water is fed into the reaction tank. Aeration can be selected according to the process. The second stage is the reaction period. Aeration is carried out during this period. Activated sludge under aerobic conditions. Degradation of organic matter in sewage. The third stage is the sedimentation period. After the early reaction period, most pollutants are removed and then enter the precipitation period. The activated sludge is precipitated to the bottom of the tank. Aeration is not carried out during this period. The fourth stage is drainage and mud discharge. At this stage, the clarified supernatant is discharged. At the same time, part of the precipitated sludge is also discharged. The fifth stage is the idle period. At this stage, sludge will further decompose the remaining pollutants. You can also leave the system idle, waiting for the next sewage treatment cycle. Finally, the activated sludge system structure. Aeration tank. As shown in the figure, these are 3 aeration tanks. Figure 1 shows an aeration tank in operation. Figure 2 shows the aeration head of the aeration tank. Figure 3 shows an aeration tank being installed. This is the aeration tank that we are running. This is the aeration head at the bottom of the tank being installed. This is the outlet weir of the aeration tank. This is the secondary sedimentation tank. This is the outlet weir of the secondary sedimentation tank. Okay, that's all for today's lesson, students. See you later.